Okay, so something pretty incredible just went down at the crossroads of AI and super advanced math. We're talking about an AI tackling problems that even professional mathematicians find tough. And wow, the results are just stunning. So let's just get right to it. The big number, the headline, is this: 6 out of 10. An AI agent working completely on its own solved 6 out of 10 research-level math problems. And look, we're not talking about your high school algebra here. This is the real deal, the kind of math that pushes the very boundaries of what we know, which, of course, leads to the big question. How? I mean, how is that even possible? How did an AI get to a point where it can reason mathematically at this level? All right, let's dive in and break it down. Okay, first things first, we need to set the stage. We need to understand the arena, right? Because this wasn't just some random test. It was a brand new, really high-stakes competition called the FirstProof Challenge. So what exactly is the FirstProof Challenge? Well, it's a collection of 10 problems, or as mathematicians call them, lemmas. Now, you can think of a lemma as kind of like a mini puzzle. It's a stepping stone you have to solve to prove a much bigger mathematical theorem. And the key here is that these weren't just textbook problems. No, these came straight from the notebooks of top mathematicians. These were real hurdles they were facing in their current research. And the whole setup was pretty intense. You had problems proposed by this team of elite mathematicians. They were released on February 5th, and get this, the deadline was just a little over a week later. But the most important rule, the whole point of the challenge, was to see if an AI could actually solve these things completely on its own. No handholding, no human expert whispering hints. And that, of course, brings us to our champion, the AI agent that's at the very heart of this incredible story, Aletheia. So Aletheia is a specialized math research agent built by the folks at Google DeepMind, and it's running on their powerful new Gemini 3 DeepThink model.
The philosophy behind Aletheia is really fascinating. It wasn't just built to be a problem-solving machine that throws everything at the wall. Nope. It was built for reliability. In fact, Aletheia actually decided not to submit answers for 4 of the 10 problems because it just wasn't confident enough in its solutions. And that's huge, because for actual researchers, an AI that knows when it's right is way more valuable than one that just takes a wild guess.
But here's the thing. The big breakthrough here isn't just the final score. It's how they got that score. The process they used was incredibly strict, totally hands-off. Which raises a fair question, right? How autonomous was it really? That word gets thrown around all the time in AI. So what did it actually mean here?
Well, this right here tells the whole story. This is the official human-AI interaction card, and it spells everything out crystal clear. The only thing humans did was provide the problems and then do a final verification prompt. That's it. There was absolutely zero mathematical guidance. None.
So the whole pipeline was just incredibly clean. Step 1, you give the unmodified problems to the agent. Step 2, Aletheia gets to work, completely on its own. Step 3, it produces its 6 best candidate solutions. And finally, step 4, human experts come in to evaluate the final output. Super simple and totally 100% autonomous. All right, so let's get to the juicy part, the scorecard. How did Aletheia actually do? What did the human experts have to say about those 6 solutions it came up with? So here it is, the official scorecard. And as you can see, for 5 of those problems, unanimous. Everyone agreed, correct. But then you look at problem 8. Only 5 out of the 7 experts gave it a thumbs up, so what happened there?
This quote really gets to the heart of it. It wasn't that the proof was fundamentally wrong. It was more that some of the experts felt a key step, well, it just lacked the amount of detail you'd need for a formal paper. And honestly, this is exactly what happens in human peer review all the time. It just goes to show you that even among the top experts, there's a bit of subjectivity in what counts as a totally complete proof. Now, another really crucial part of their strategy was this best of 2 approach. They didn't just run one AI. They ran 2 different versions, Aletheia A and Aletheia B, and then just took the best result for each problem. It's a clever way to build in some diversity. If one version hits a logical dead end, maybe the other one finds a completely different way to solve it. It's a great way to guard against any single model's blind spots. And this right here shows you exactly why that was such a brilliant move. Take a look at problem 7. A's attempt was critically flawed, but Aletheia B nailed it. Perfect. Same with problem 8.
A's solution was inadequate, but B came through with the version that most of the experts ended up approving. So yeah, this best of two approach made a huge difference to the overall accuracy.
And speaking of problem 7, whoa, look at that massive spike for it on this chart. This shows the inference cost, basically how much computational muscle each problem took. And there is a very good reason for that spike. It turns out problem 7 wasn't just some tricky lemma. It was actually considered an open problem in the field. So Aletheia didn't just solve a hard step in a puzzle, it autonomously solved a question that was previously unsolved. That's a huge deal.
So, what does all this mean? What's the big picture takeaway when you step back from this incredible achievement? Well, it really points toward a brand new future for how we do scientific discovery. And let's be super clear about one thing. The goal here with an AI like Aletheia is absolutely not to replace human mathematicians. It's about collaboration. That's the real goal. It's about creating a totally new kind of tool that can work with human experts, almost like a partner. An AI that can augment our own abilities, take on the really tedious or computationally heavy lifting, and maybe, just maybe, spot connections that we might have missed. Look, this whole experiment proves that AI is now capable of solving those really difficult intermediate steps in modern research. So the question really isn't if AI is going to impact mathematics anymore, it's how. It makes you wonder, if AI can help us prove today's lemmas, what incredible new theorems are we going to discover tomorrow with these new collaborators by our side?